Hello, everybody. In fact, hola. And I'll defer the goodbye now because I might forget later. So, I've been doing Go for a long time, and I talk about I've been building services for 8 years. That's not really to say, therefore, you should do it this way. It's just, it works. That's all I mean. So I'll talk a bit more about that too. I'm on Twitter, and I like to engage with people on Twitter and meet people on Twitter and stuff. So if you've got any questions about this or anything, it's just Matt Ryer on Twitter. Please engage. Let's do it. And also, I do the Go Time podcast, which is a live podcast on Tuesdays, which is very fun, and I get to talk to some really interesting people and stuff. So it's great. So, and that's that. I just watched this talk in the other room. Tom Ogoma did a talk that actually covered a lot of the things that I'm going to talk about too. And I do recommend it. He goes into different detail on different things, which is great and interesting. So last year I wrote a blog post about how I write HTTP services after 7 years. This is like the sequel to that. I'm sort of taking it on tour, taking the blog post on tour. It went a bit viral, and it was the most clicked story in the Go weekly newsletter. And notice in the little description, they say, amazingly, this was the best, or the top story, right? That's an insult. But I know what they mean, because basically there are a lot better written stories and articles on the newsletter. There were some really kind of awesome projects and sexy things and stuff. But at the end of the day, we've got a job to do, and it's nice to get that done. And I think that's what this really tells me about this, and that's why I'm doing the talk. Also, I learned, did you know that you can write nice things into Reddit? Yeah, so I didn't know you were allowed to do that, but yeah. So some of this feedback was incorporated into the blog post and now into this talk and stuff. So, it's not really about me. This is about really the community, I think. And also, I pair almost exclusively with David Hernandez, and we founded Machinebox together with one other. And so this is a lot of influence comes from David as well, and it's so I'm just going to present it, but and take the credit for it, So how I think you should use this talk, and probably every talk, is not to just take it literally, and don't just blindly follow these as like rules. These are do's and don'ts. None of software is really like that. A lot of software it's trade-offs. Sometimes it's, I just prefer this way. You can do it lots of ways. I just like this way. So that's the spirit in which this is intended. It's not meant to be a kind of scripture or anything like that. And you should just try things out for yourself in your team, because you know best about your context. And the context is quite important when it comes to making decisions about what you're doing with your code and stuff. And I always say, why not carve out some of the week to do that deliberately? The team benefits, and it's fun to do, and the projects are better for it. So if you can, carve out some time to experiment and try things. It pays dividends. So whenever there are lots of different ways to do things, I tend to select for these things. I tend to select for maintainability, glanceability, which isn't a word. So if English isn't your first language, don't learn from me. Okay, that would be a mistake. Glanceability, though, if you just look at the code, how obvious is it what's happening? How long does it take to figure out what's happening? And even if it's code that we wrote last week, it's the same. We forget that, we move on. We've only got a certain amount of RAM in our brains. And so that glanceability is really a key part of maintainability. So I like obvious code. I like things to be really expressive. I know it's really clever when you can write programs just on one line, but I don't do it, and I don't like it. And actually, the Go format stuff helps, helps us with that too. And also, as we learned, because the community growing so much, a lot of people are new. So that means we can choose to write code that is ultra simple and just helps new people as well. Okay, so I use this, in a few of the samples, I use this mini testify called is, which is like a really lightweight version of testify. So you'll see that, so don't worry, you know what it is now. Some of the code is illustrative, it's not literal, but I've tried to keep it real as much as possible. And check out Julie Q's talk from this very conference. It was actually the talk before me here. She talks about how to select dependencies. Some people are like standard library fundamentalists, and they think you only need the standard library and nothing else. But as we learned from the success of this story, we have a job to do. We don't have time to write our own routers and things like this. So, of course, we're going to use things from the community that other people have written. So, there we go. Let's jump in. That photo was taken yesterday, by the way. Imagine that. Okay, so we'll just get into some real actual code now. I always have a server struct, and I put the dependencies into that server struct. And this means that we can share those dependencies with the handlers, and it also makes sure that we don't have any global state. Peter tweeted this a few days ago. His advice, no global state. If you avoid global state in your code, you get rid of a whole class of potential trouble, potential bugs, gone. So that having a server struct does that, because the server, you have all your dependencies in there rather than just variables. I do end up with a constructor for that server, because there's usually some more setup that needs to happen, whether it's actually adding the routes and perhaps there's some configuration things. But don't set up the dependencies in here, because when it comes to test code, you probably want different dependencies. So it's a little bit counterintuitive. You'd expect new server to just create the whole thing and you're good to go. But you hurt testability if you do that a little bit. If you only have a couple of dependencies, then you could take them in as arguments. But usually, it gets messy. Anytime there's like 3 or 4 arguments, 5, it's too many, I think. So, and that's sort of the point of the server struct anyway, is to encapsulate those. So I have a routes.go file, and this turns out to be extremely useful. I basically just do all the routes in one place. I've seen code that had the routing spread throughout, or they had it near the implementation, which I understand. But when it comes to maintainability, whenever you get a bug report, or whenever someone's referring to something about your service, it comes with a URL. So it really makes sense to go straight to that URL, find, this is the path, this is the handler, I can see where to look for this. So that really helps. And it's also nice, you get a kind of map of the service. My handlers hang off the server. So they are methods on that server, and this is how they can access those dependencies. You can see that the S is available to the handlers. I don't know why it's flashing like that. Is it flashing, or are my eyes turning off and back on? Yeah, right. But if you do this, remember that the other handlers also have access to these. So you have to remember that every HTTP request gets its own Go routine. So you have to remember, if you're going to be accessing these dependencies, it's got to all be safe to do concurrently. And most of the time, you sort of get that for free. But if you've got some of the data in there, that you're part of your use case that you're using, you've got to remember to protect that data and don't get any data races or anything. I name handler methods like this, and I kind of, again, this is a little bit counter to my intuition, because I like it to just be expressive. I'd like it to say, handle get tasks. I think that scans easier. But the benefit of this is, in the IDE and in the docs, it's ordered and they're grouped, and that also is very quick for finding things, finding the right thing, and maintainability. I actually return the handler. And I'm not talking about middleware, I'm talking about the handlers themselves, because you create this little environment where you can do other things. You can do handler-specific setup, and like here, I have a thing, and then in the handler that I return, I can use that thing. It gets closured in. And notice that you just return an anonymous function here, and that becomes the handler. So that's different to just having this function with that signature as the method, and then just referring to that. This actually, you call it in the routes file, and you can do some setup at that time. You can also take in arguments too. So in this case, I've got this handle greeting handler. I take in a format. So I can have different greetings just by using the same handler. And anything that has to happen, they'll each get their own little private closure environment. So they sort of exist on their own. They're independent, but of course they have access to the shared dependencies via the server. So it works quite nicely. Here's a few other examples of things. The other thing this does is it makes it very clear what that handler needs in order to do its job, right? And in fact, you can't get the handler without providing those things. So I think it's quite nice. You get all the type safety, type checking, and things like this. It's the opposite of putting dependencies in the context or something like that, where you only find out if it's right at runtime. This is a compile time check. So you get that immediate feedback, which is important. I tend to now prefer HandlerFunc over Handler. And that's just because, if you don't know, HandlerFunc implements Handler. Handler is an interface that has a single method, and HandlerFunc is a function type that happens to match that method signature. And so it then has a method on it that is the serve HTTP method that just calls itself. So it is if you haven't seen it, check out the code. It's only a few lines of code, but extremely powerful, and it's something that you can borrow as well in your own designs. I love it. But it essentially means you don't need to create a type to create a handler. You can just have a function. You can just use anonymous functions. And that's how I'm able to just return that func there. It'll get cast into the HandlerFunc type for me. So it's nice. You sometimes have to switch between them, because a lot of if you're using, like, there's a cause package that provides the HTTP cause stuff for your server. And that all deals with handler type. So sometimes you have to do a little bit of changing between them. And if you find that you're doing too much of that, maybe handler is a better option in your particular case. But just for me, generally, I tend to use HandlerFunc. And so middleware, I guess we've seen this pattern now already. I think it's been around a while. But it's really cool that they're just Go functions. And the idea generally is you take a handler and you return a new handler, and you have the opportunity to run code before and after, so you can do various things. In this case, it's checking to see if the user is an admin, and if not, it says HTTP not found, and doesn't actually run down and call the handler. So you shortcut it like that, and this little pattern is useful for lots of different things. And I wire the middleware up in routes.go. So this also gives you more information. When you glance at your service, you almost see the footprint or the API surface of your service. And you can see that this /admin at the bottom, it has the admin-only middleware for the handler. So it's very clear to see what's going on and what applies where and things like that. Yeah, is it flashing? I tend to abstract the responding. Early abstraction is something that we should all be fighting every day. As programmers, we really feel like we want to create that abstraction at first. We want to create the abstraction for our case, and then we've multiplied the value, right? That's how it feels. But in practice, most of the time, we don't have enough information that first time we're implementing it. So it's worth resisting doing. And just implement it a few times first, and then there might be an abstraction that's clear. But this is one that I found to be really useful. Just having a general way, just another method on the server to respond allows us to support other things later without touching any of the rest of our code. So that's kind of like the sweet spot of an abstraction. And you can do the same thing for decoding. If you're getting, if you're building a JSON API, then you can decode that. And the first version is probably going to look something like this, and it almost feels like a waste of time. But this allows us to later check. We could check the content type and decode data in different ways. We've got a lot of flexibility there. And anytime you write helpers like this, which you don't, this is where you don't need external dependencies for, I don't think. But whenever you write these handlers, take in the response writer and the request, even if you're not going to use it initially, because you don't really want to break APIs too much if you add things. And these are the only two things you need in order to do everything to do with HTTP and Go. So it's kind of perfect. This is cool. So usually, if it's a JSON API or any API, you have data types. You have a request and a response. Well, because you've got this little private closed environment, you can just create the types in there. And what that does is everything to do with handling this greeting is now in one place. Everything to do with the HTTP parts, the data, all that's just neat and in one place. And it declutters the package space. So you don't have all these types that are going to show up every time you're trying to code stuff. Even if it's not exported, when you're writing code, you're going to see it in the list. So hiding these in there gives you the opportunity to clean that up. And since naming things is one of the hardest tasks in software engineering, you can just call them all request response. They can have the same name. They don't all need different names. So I feel like that's a really nice little pattern. Imagine a new person coming to the project and they said, can you go and add something to this greet API? It's really clear, I think, what the ins and the outs are of this endpoint and what data and what fields there are and where you would have to change things. But of course, it means then that these types aren't available anywhere else. They're available inside the handler, which is where we need them. But what about testing? And actually, probably you still don't need them because you can just create types like this, as simple as anonymous struct, implement it immediately, and you've got yourself the data that you need. This is a great storytelling opportunity because, as you can see, there might be a concept of a person in this application that might have name, address, profile picture. There might be lots of data. But in the test for the greeter, we're only dealing with the name. So we're making it very clear that, yeah, whatever else is going on, this endpoint just cares about this. So it gives you that glanceability where you can just quickly remember or figure out what's going on. Has anyone used sync once before? Okay, so sync once it's really cool. Essentially, you give it a function, and it will guarantee that that function only gets called once. And that works in a concurrent, safe way. Remember that every request is its own HTTP. Every HTTP request is its own Go routine. So we have to care about that. If we're going to be changing, like passing a template and saving it, if we do that and two things come in at the same time, we could get a data race. So sync once protects against that. And then we just handle the error as we do in the usual way. It's closured in, so it's all local and safe. And it will defer the actual setup until that handler is called the first time. And if you use something like App Engine or any of these services that scale down to 0, then startup time is something that you care about. You want it to be really snappy. And so this is a nice way to do that. It also means that if this handler is never called, that setup work is never done. So, but it depends, right? Your deployment situation might be you deploy it and it stays forever, stays running forever, in which case maybe you just want to deploy it and get all the hard work out of the way. So it's a choice you get to make. But this is a nice pattern, I think. You can make the server itself an HTTP handler just by implementing this method. That's the point and the power of single method interfaces. So now our server is an HTTP handler. And basically, you usually just pass execution to something else, the router usually. It's tempting to add things in here because it's global. You know that every request is going to go through this. But I would resist that because it's not going to be obvious to people that that's where this functionality lives. So just keep it dead simple. If you want to do something global, then you can use a middleware and apply the middleware to the server. And at least then you're being very explicit. Server is testable. And this is what's nice about this now. Since those dependencies are in there, we can just put in test dependencies and make sure that the code's doing what we want it to do. Or we could use real database or whatever, but we get control of it in our test code. And then use the HTTP test package from the standard library to create a recorder and a request and do that. You have a choice. You can either call serve HTTP in your tests, which tests the whole stack, the router, the middleware, everything. Or you can just directly call the handler itself and cut out all the middleware. So if you think about unit testing, then this bottom one is better, because if that admin-only middleware gets a bug or breaks, you don't want all of your tests to fail. So you only really want the admin-only test to fail. So you get that protection. And you can test the middleware as well. So you can see here that I create in test code, I just create a little handler, because they're very easy. It's just HandlerFunc. And all I'm doing here is going to increase a counter. And then you can make 2 requests and guarantee really that the behavior is what you expect. So in this case, I do a check with a fake that shouldn't get through, and then I do one that should get through. And this is only testing the admin-only middleware. It's nice when there's a bug. It's nice that if you can get it so that one test fails, it just points exactly to where that bug is. If there's a change that introduces a bug and your entire test suite fails, you still have the job of going to try and figure out where the problem is. So isolating things like that is quite a good practice too. And that's it. I want to add my thanks to the conference organizers and say, welcome to all our diverse friends. And I want to do this call out to all the weirdos. Anyone that's not been welcome in other tech communities, come to Go, because you are welcome here, and the diversity is what makes this actually so much stronger. That's not a new operating system I'm working on. although it would be cool. Thank you very much.